Some functions can be thought of as the result of either adding two functions together, subtracting one from the other, multiplying two functions, maybe even dividing them. Another way that we can combine functions together is by what's called function composition. We can also build new functions by taking two separate ones and adding them, subtracting one from the other, or multiplying them, or dividing them, or composing them. So let's briefly review how we can combine two functions together in order to create a new function. Let's consider f of x equals x squared plus 7 and g of x equals the square root of x minus 1. Now these are both functions even though I'm not calling them both f of x because they're different and I want to be able to refer to each one separately. We normally use things like f, g, h to denote functions, but we could use whatever letters that we'd like. In part 1, we are finding f of x plus g of x. This is really as simple as it sounds. We're just going to take f of x, which was x squared plus 7, and then we will add g of x, which is the square root of x minus 1. Now we can simplify if possible, but in this case, there's nothing really to do here to simplify this, so this is just the sum. The difference, f of x minus g of x, is also as simple as it sounds. We will just take f of x, which is x squared plus 7, and then we will subtract g of x, which is the square root of x minus 1. Again, nothing to do here to simplify, so this is the difference. In example 3, we have f of x times g of x. Again, that is just like it sounds. We will just take f of x, x squared plus 7, and multiply it by g of x, the square root of x minus 1. Nothing really to do here to simplify, so we can leave it just like this. In example 4, we have f of x divided by g of x. Again, that is as simple as it sounds. That is just x squared plus 7 up top, and then we'll divide by g of x, which is x square root of x minus 1. Now notice in each one of these four situations, we have created a new function out of the other two. We've done this by doing operations on the two functions that we can also do with numbers, like we're familiar with addition, subtraction, multiplication, and division. The last two examples here are things that we can't really do with numbers. This is called function composition, and it's when we put one function inside of the other as its input. You may have seen this notation before. This f circle g of x means that we are going to put g of x inside of f of x. So this is read as f of g and then of x. So one way that we could kind of visualize this is to say that this is the same as f of g of x. And now this notation tells us that the input that's going into the f of x function is actually the entire function of g of x. So if we look back at what f of x is, it's x squared plus 7. So we're going to substitute in for x the entirety of g of x because that's our input into the function f of x. If you like, you can also write this as f of the square root of x minus 1, just substituting in the formula for g of x. Again, we're just going to substitute this into x into the f of x function. So we will square the square root of x minus 1, and then we will add 7. Now here we can simplify because if we square the square root, that just cancels out. We will just get x minus 1 plus 7, and negative 1 plus 7 is positive 6. So this one simplifies to x plus 6. In the last example, we have another function composition, but it's written in a different way. It's kind of written in the way that I translated this circle notation or this composition notation into, I don't know which way you think is easier, either this way or this way. Whichever one you prefer is fine with me. We should be able to kind of use both. So now we're composing in the other direction. Here we're putting f of x as the input into g of x. So we're going to be substituting in our entire f of x function in for x inside the g of x function. So if you like, we could write this will be g of x squared plus 7. And then again, this is our input, so we're going to substitute that in for x into the g of x function. That is the square root of x minus 1. But instead of x, we're substituting in the x squared minus 7. Here we can simplify x squared plus 7 minus 1. That's just the same as the square root of x squared plus 6. There is our function composition. Now notice that composing things in the opposite order, like in example 5, we had f of g of x, and in example 6, this is g of f of x. If we compose things in the opposite order, we don't usually get the same thing. So it is important to take note of the order and compute the composition accordingly.